Electric heat service calls.
Hi, I'm Alan Pratt. For most of human history, the way to generate heat has been to burn something: wood, coal, oil, or gas. But with the discovery of electricity, a new method of generating heat came into being, one that depended on the movement of electrons in a wire. It's easy to demonstrate. This dry cell battery has a positive terminal and a negative terminal. When these two terminals are connected with a wire, electrons, which are negatively charged, will move through the wire from the negative terminal to the positive terminal. For a wire, I'm going to use this steel wool. The steel fibers resist the flow of electrons, causing friction. The greater the resistance, the greater the friction. And as everyone knows, friction causes heat. Watch. Well, that's the basic idea behind electric heat systems. Current flowing through a high-resistance heating element causes heat. In this program, you'll see how two technicians use their troubleshooting skills to solve problems with electric heat systems. But first, let's take a look at the components that make up a modern electric heating system.
Electric heat systems consist of one or more strip heaters. Each strip heater includes electric heating elements, limit switches, and fusible links. The heating elements produce heat by converting 100% of the electrical energy used into heat energy. Each watt of electrical energy produces 3.415 BTUs of heat energy. The limit switch is a safety device with a temperature setting that can vary from 130 degrees to 190 degrees. If the temperature of the heating element begins to exceed the setting, the switch de-energizes the heating element. Another safety device is the fusible link. It protects the heating elements from burning out if for any reason the fan limit switch fails. The strip heaters are energized in a sequential order by either relay contactors or sequencers. Both use bimetallic contacts that are normally open. They close when the control circuit delivers 24 volts.
Now, let's take a minute to compare some of the differences between relay contactors and sequencers.
When a call for heat occurs, a relay contactor uses a low-voltage solenoid coil to close the electrical contacts to the strip heater. Inside the sequencer is a low-voltage heater element called a heat motor, which energizes the electrical contacts. Relay contactors will contain one or two normally open contacts, whereas sequencers may contain 4 or more sets of electrical contacts. The heat motors in the sequencers control the sequential operation of multiple banks of strip heaters and allow for delayed blower operation. With sequencers, the blower motor must be wired into the circuit so that it is energized either at the same time as or slightly before the first heating element. Another component is the fan center relay, required when adding air conditioning to an electric furnace. This relay energizes the blower at low speed for heating and at high speed for cooling. Most manufacturers recommend 400 CFMs per ton for both air conditioning and electric heat.
So, that's a quick overview of the components used in electric heat systems. Now let's watch a technician use his troubleshooting skills to solve a problem with electric heat.
Electric heat? That's a pretty expensive way to heat this house.
Yes, I know it is.
Why aren't you using a heat pump?
Because it broke last week and they had to order parts. Until they could order the parts, I had to use the electric heater.
But you turned the electric heat off.
Yes, I did. This morning it was cold and it wasn't working, and I was afraid it would burn up.
Well, how did you turn the electric heat off?
At the thermostat?
Okay, I'll check things out. Can you show me where the thermostat is?
Sure, right around the corner.
Okay.
The thermostat is turned off as the customer said it was. When you turn the fan switch to the on position, there is airflow at the register. Next, try turning the fan back to the auto setting and set the selector switch to the emergency heat setting. At the register, there is no airflow, but you can smell a definite heat odor, which indicates the heating elements are being energized. When you're finished with your inspection upstairs, turn the thermostat to the off position and check the furnace in the basement. Start by turning off the service switch at the air handler. Then remove the furnace compartment panel. Next, look for signs of burnt wires or controls. Since everything appears to be okay, check the electrical schematic next. A review of the blower circuit shows that the blower is energized by the blower time delay relay at relay terminals 1 and 2. To check the time delay relay, remove the motor lead wires from terminal 1 and 2. A resistance check across terminals 1 and 2 shows a reading of infinity, indicating that the fan circuit for the emergency heating cycle is open. The problem is now clear. The blower time delay relay is bad and will have to be replaced.
Amy.
Before you begin any repairs, explain the problem to the customer.
Probably cost about $80.
Okay, go ahead.
Make sure you receive approval to perform the necessary repairs. Then go ahead and install a new blower time delay relay, replace the compartment panel, and turn the service switch back on. Back upstairs, reset the thermostat to the emergency heat setting and check the register for airflow. Then check the supply air temperature. The reading of 117 degrees shows the strip heaters are supplying adequate heat. To complete the service call, explain the charges to the customer, make sure the invoice is signed, and that you answer any customer questions.
Yes, we do.
Well, maybe I'll have you come back in the spring.
Great.
Okay, thanks.
You can see how the lack of ignition and combustion problems can make an electric heat service call relatively easy to deal with. Now let's look at another troubleshooting situation.
Hi, I'm Randy from ProTech.
Glad you can make it.
I understand you don't have any heat in the building?
Well, just in the classroom area particularly. The rest of the building is fine.
So the whole church is electric heat?
Yeah, there are 4 electric units on top of the roof.
So it's just a classroom that has the problem?
Right. There's some warm air coming out, but it's definitely not as warm as it used to be.
Okay, when did you first notice this problem?
Well, we recognized it on Sunday morning when the kids had to wear their jackets to Sunday school.
Okay, so each system has its own thermostatic control then?
Yes.
Okay, will you show me where the thermostat's at and we'll see what we can do for you?
Sure, that'll be great.
Okay.
As the customer said, the room temperature is only 64, but the thermostat is set at 74. The airflow at the supply register is adequate, but the temperature is only lukewarm. Next, go to the roof and do a visual inspection of the heating system. The unit is running. Start by turning the disconnect off and removing the compartment panel. This system is a 240-volt, 3-phase system with 3 sets of 18 kilowatt strip heaters. These are staged to provide increasing levels of heat. 1, 2, or all 3 may be energized at the same time. The wires and controls seem to be in good condition, with no signs of burning or other deterioration. Since the room temperature is 10 degrees below the thermostat setting, all the strip heaters should be on. So the next step is to check the amp draw of each strip heater. First, turn the disconnect back on. Then check the amp draw of all 3 phases of each strip heater. The amp draw of each phase of the first strip heater is 43 amps, which is within range. Each phase of the second strip heater is drawing 0 amps. The amp draw of each phase of the third strip heater is 43 amps.
Since the second strip heater isn't drawing any amperage, you might assume that it's bad and needs to be replaced. But that would be a mistake. The problem could also be in any of the other components in the strip heater circuit. So, to isolate the problem, you'll need to refer to the schematic.
The schematic shows that the second strip heater is energized by Relay Contactor number 2. The number 2 Relay Contactor is energized, but a voltage check at the supply indicates 0 voltage.
Now you know why the second strip heater isn't being energized. There's no supply voltage at the relay contactor, and that means there must be an open somewhere in the heating bank circuit.
The schematic shows that the supply voltage leg for each relay contactor is protected by a fuse at a central fuse block. To check the fuses, turn the disconnect off. Then lock and tag the unit. Next, locate the fuses for the number 2 contactor. Remove each fuse and check its resistance. The ohm meter shows a resistance of infinity for both fuses. The fuses are bad, but before replacing them, check to see if other faulty components in the circuit may have caused them to blow. Start with the heating element. The resistance is within range. Since the heating element is not energized, the limit switch should be closed. Check that next. The reading shows that the switch is closed. Now you know for sure the only problem with the strip heater is 2 bad fuses. Before continuing, explain the problem to the customer, estimate the cost of the repair, and get the customer's approval. Then go ahead and replace the 2 blown fuses. Remove the lock and tag, and turn the unit back on. To test the system, allow it to run for 5 minutes, and then check the amp draw of the second strip heater. 48 amps is within range for this heater bank. Your work on the roof is complete once you have replaced the compartment panel. Back inside, check the supply air temperature in the classrooms to make sure it's within range. Complete the service call by explaining the charge on the invoice, answering any questions the customer may have, and making sure all paperwork is complete.
Well, that's it for now. I hope this program has helped you identify some ways you can brush up on your troubleshooting skills when dealing with electric heating systems. So long.